Phew. As all these ions with different names imply, chemical nomenclature isn't a trivial issue. But at least the names of binary compounds, compounds made up of two elements, follow a regular pattern. We first need to determine whether the compound is ionic or molecular. Ionic compounds are also called salts and contain a metal cation and a non-metal anion such as KCl. In contrast, binary molecular compounds contain two nonmetals, such as disulfur dichloride, S2Cl2. Let's look at naming ionic compounds. The metal cation is always listed first and the non-metal anion second. The metal retains its usual name and is followed by the name of the nonmetal with an "ide" suffix. There are no prefixes used when naming an ionic compound like di or tri, even if the ionic compound contains more than one atom of a certain element. So CaF2 is calcium fluoride, not calcium difluoride. The reason for the no prefix rule is that the ionization behavior of calcium and fluorine is predictable. We know, based on periodic trends, that calcium from group 2 will form a +2 ion, and fluorine from group 17 will form a -1 ion. This trend itself is one of your most powerful tools when dealing with ionic compounds. Even if an ionic compound looks intimidating, chances are you can figure out at least one of the charges using the periodic table and then understand that the counter ions must total an equal opposite charge. However, groups 1 and 2 aren't the only metals in the periodic table. We also have transition metals, which can seem less predictable. These metals often have multiple oxidation states, so we specify their oxidation number when naming their ionic compounds. To accomplish this, a Roman numeral is used to indicate the charge on the metal. This tells us how many electrons the transition metal has lost and provides the information we need to predict how many atoms of a corresponding nonmetal it will be partnered with to form a neutral ionic compound. For example, iron 3 oxide has Fe3+ paired with an oxide anion O2-. So the chemical formula of the neutral compound is Fe2O3, which is commonly called rust. In contrast to ionic compounds, molecular compounds are composed of nonmetals only, and their chemical nomenclature is relatively simpler. The atoms in the chemical formulas are usually arranged in order of increasing electronegativity. Per our earlier example, disulfur dichloride is S2Cl2. However, carbon is always written first, as in methane, CH4. And in compounds that don't contain carbon, hydrogen is written after nitrogen, like in ammonia, NH3. The suffix "ide" is added to the end of the name of the second element, and prefixes are used to indicate how many atoms of each element are present. The prefixes are based on the Greek language, so you may have encountered them before in sciences. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, and so on. There's just one catch. If there's only one atom of the first element, the mono prefix is left out. For example, CO is named carbon monoxide, not monocarbon monoxide. To help you contextualize this material, please recognize that you're unlikely to be tested directly on questions like, what is the correct name of N2H4? Or what is the chemical formula of potassium phosphate? Instead, problems often assume a fundamental knowledge of this material, so they might discuss common compounds by name without showing the formula or vice versa. Another common piece of question logic is inferring the charge of one ionic component due to knowledge of another, like being able to distinguish the different oxidation states of iron in FeCl2 and FeCl3 by knowing that chloride's charge is -1. All that is to say, investing some time up front in reviewing this material will set you up for success later on.